I'm Anil Kumar sharing with you few multiple choice questions to warm up for test on derivatives. Now this video is good for IB students and the students who are taking AP calculus. All the questions are multiple choice, very simple, just to review the concepts. You can always pause the video, copy the question, answer them, and then in the later half, I'll answer them one by one. So the very first question here is, you are given graph of the function f of x, and you need to find derivative of the given function is negative in which interval. 4 options are given to you. The next question here is, this time you are given graph of the derivative and you need to find where is the function f of x increasing. Next question here is a true or false question. You need to provide reason for your answers. The first one is, slope of a function f of x can be 0 for all values of x where x belongs to real numbers. B is, a continuous function is differentiable in its domain. If f of x equals to x squared times x cubed, then derivative is 2x times 3x squared. And D is, if f of x equals to square root of x, then derivative of the function at x equals to 0 is 0. The question here is, functions differentiable at origin are, which one of these are differentiable at x equals to 0? Number of real roots for polynomial function 10 plus 3x plus 5x cubed are 0, 1, 2 or 3. Now the question is, for how many values of x can the function f of x equals to x cubed and f of x equals to 1 over x have the same slope? You have 5 choices. The question here is, the height h in meters of an object is given by h of t equals to minus 5t squared plus 90t, where t is between 0 to 18, and where time t is time in seconds. During which interval of time is the speed increasing? Based on similar formula, we have another question. Says the height h in meters of an object thrown vertically upwards with initial velocity of v0 is given by h of t equals to minus 5t squared plus 100t plus 25, where t is time in seconds. Initial velocity v0 of the object is, 5 choices are given to you. We're almost at the end. The question here is, if f of a equals to 0 and derivative of a at a is 6, then limit of the function as h approaches 0 for f of a plus h divided by 2h is 0, 3, 6, 9 or 12. Here's the last question. Slope of the tangent line to the curve 1 over x plus 1 over y equals to 1 at the point P 2, 2 is which one of these, right? So I hope you have made a note of these questions. Once you're done, look into my solutions. And now, let us solve them one by one. Now let's solve these questions one by one. Graph of the function f of x is given to us, right? So that is the graph of the function. Derivative of given function is negative if the interval, what out of these? So derivative basically is slope of the tangent line, right? So if you see this graph and if you draw a tangent line, at x equals to 0, it is horizontal. On the left side, it is negative. On the right side, it is positive, right? So negative means decreasing. Derivative of the given function is negative in the interval minus infinity to 0, right? So that's the correct answer, which is option A, right? Next question. We are given the graph of the derivative this time. So let's write f dash x. The function f of x is increasing in the interval. Which interval is the function increasing, right? So this is the graph of the derivative. Now what you notice here is that if I look at this graph, then you will notice that the derivative f dash x is positive from minus infinity to minus 2, negative thereafter up to 2, and then from 2 to infinity it is again positive, right? So at two places, at minus 2 and plus 2, the derivative of the function is 0. So these places are the turning points, right? These are turning points for the function. Since it is positive here, that means the function is increasing in the interval minus infinity to 2, right? So it's kind of like this. The function is kind of increasing in this interval. Now here it is 0, so that's the turning point. Do you understand? Negative derivative means it is decreasing. It's kind of decreasing until it hits derivative 0. So now you have clear idea of the function itself. So this is how the function is going to look like. It's easy to answer it now. The function f of x is increasing in the interval. So these are the two intervals when it is increasing. That is to say, minus infinity to minus 2 and 2 to infinity. So I hope this concept is clear. So let's move on. Here is true or false question. It says, provide reasons for your answer, right? The first one here is, slope of function f of x can be 0 for all values of x, where x belongs to real numbers. Well, if you take function which is a constant, let's say 5, right? Then what is the derivative of this function? Is 0. So any function which is a constant can be represented with a horizontal line, right? Can be represented with a horizontal line. Slope of the tangent is going to be 0. Derivative will be 0 in its entire domain. So this statement is true. The next one here is, a continuous function is differentiable in its domain. Well, there are many examples, as you know, where the functions are continuous, but they are not differentiable. For example, the absolute function itself. So whenever there is a corner or a cusp, right, or even you could have a function which has vertical tangent line. For example, a function like this, right? These functions are all continuous, but they are not differentiable, right? So giving you examples, let me write. This is graph of cube root of x. This is graph of absolute value of x. And this is graph of x to the power of 2 over 3. Then part C is, if f of x equals to x squared times x cubed, then the derivative is 2x times 3x squared. Well, that is absolutely wrong. This is false. Well, let me write for B also. Continuous functions are differentiable in its domain. That is false. Not always true, as we have few examples here contradicting it. Now, if you have a function as product of all this, I could write this as x to the power of 2 plus 3 is 5. So what is going to be its derivative? 5x to the power of 4 is going to be its derivative. Is that okay? So you can combine them and write like this. And this is absolutely wrong. Part D is, if the function f of x equals to square root of x, then the derivative at 0 is not 0. It is undefined, right? So this is also not true. You are writing function f of x as x to the power of half, right? So the derivative of this function will be half times x to the power of minus half, or you could write 1 over 2 square root x. If I substitute 0 here, 1 over 0 is not defined, right? So 1 over 0 is not defined. So the derivative at 0 does not exist. Is it okay? So that is very important to understand. So it does not exist at x equals to 0. Even otherwise, let me show you graphically. We could sketch this function as kind of like this. Now it's kind of a point from where the function starts. You cannot approach from the left side, and therefore limit from the left side cannot be found. So the derivative does not exist. Okay, so you could explain it in that fashion also. The next question here is functions differentiable at origin are. So we have a couple of examples here, and out of all these examples, the only function which is differentiable at origin is this function, right? Now I'd like you to explore it in more details and then answer. Well, the first one I could sketch as x divided by absolute x. Absolute x is kind of a piecewise function, right? So it is negative when x is less than 0. So you get a curve like this, and it's positive when x is greater than 0 and x cannot be 0, right? That's the restriction. So it is not differentiable at origin, right? This function, however, we have taken it as one of the examples, and I will actually share that link with you. So if x is positive, it is like x squared, so it could be like this. If x is negative, then this is minus, right? So the function is kind of like this. So this is an odd function, right? And it is differentiable in its domain at 0. G dash of 0 is actually 0. This horizontal x-axis is your tangent line at origin, right? Now we have cube root of x. So if you sketch cube root of x, what do you get? The function is kind of like this. And at 0, the slope of the line is vertical, right? That means 1 over 0, which is undefined, so that is also not differentiable. And in this particular last one, rational function, we have a restriction that x is not equal to 0. So if x is not in your domain, you cannot really draw a tangent line at this point and find its slope, right? Now here is the next question, multiple choice. The question is, number of real roots for the polynomial 10 plus 3x plus 5x cubed are 0, 1, 2, or 3. How are you going to solve this? Well, we can find the derivative of the polynomial. So what is the derivative of this polynomial? Derivative of 0, 10 is 0, then 3x is 3, and we get 10x squared. And what you notice here is that this derivative is always greater than 0, right? 10x squared. So for all values of x, it is positive. And then we add 3 to it. It is always greater than 0. And that means that the function polynomial p of x is always increasing. If the function is always increasing, kind of going like this, and it's not turning back, we cannot have more than one real root, right? So the answer is 1. So this polynomial function will have only one real root. So I hope the concept is clear. Let's move on. The question here is, for how many values of x can the following function f of x equals to x cubed and f of x equals to 1 over x have the same slope? Well, in the last video, last section, we saw that the derivative of x cubed is always positive, right? Now for the second function, which is 1 over x, what is the derivative? The derivative is, you could write this as x to the power of minus 1. It is minus x to the power of minus 2, or negative 1 over x squared. So what you notice here is that the derivative of this function, reciprocal function, is always less than 0, right? And the derivative of the cubic function is always greater than 0. So that means we will not have same slope, right? So there are no points where these two functions can have same slope. We're almost at the end. 2 more questions to go. The question here is, the height h in meters of an object is given by h of t equals to minus 5t squared plus 90t, where t is between 0 to 18 and t is time in seconds. During which interval of time is the speed increasing? Well, the key word here is speed. Speed is absolute value of velocity. Remember that, right? Velocity could be negative or positive. Speed is always positive, correct? We are given 5 options. I'd like you to pause the video here, answer the question. Well, let's first find the velocity from the given equation. So we have h of t as minus 5t squared plus 90t. Derivative will give us the velocity, which is minus 10t plus 90. Correct? Now, if you kind of sketch this, it's a linear function, right? So we are saying that the velocity could be sketched kind of like this. This is velocity with time. This is time. If t is 0, it is 90. And if t is 9, it will be 0, right? So it's kind of like this, where this point is at 90 and this is at 9, right? Now, in this duration, you find that the velocity is decreasing. It is positive, of course. And if we go further, it is going to be negative, right? As you can see, the magnitude of velocity decreases up to first 9 seconds. And after that, the magnitude of velocity increases. So if I have to sketch speed, which is magnitude of velocity, I'll have to draw a curve like this. Do you see that? Clearly, you can see that the speed decreases in first 9 seconds and increases thereafter up to 18 seconds, right? Up to 18 seconds. So the option which fits in is option C. Speed increases from 9 to 14 seconds, right? That's the solution. Next question is related to the similar equation. The height h in meters of an object thrown vertically upwards with initial velocity v0 is given by this equation, where t is time in seconds. Initial velocity v0 of the object is what? Well, if you see the equation, you could straight away write that initial velocity is 100. Now I'll show you how. So we have this function, height with respect to time is given as minus 5t squared plus 100t plus 25. If I substitute t equals to 0, I get 25. This is actually the initial height. I'll call this as h0. This is initial height. Now if I find the derivative, I get derivative of height with respect to time as minus 10t plus 100. So what is the velocity when t is equal to 0? It is 100. So that's how you get your answer. So in any equation which is kind of given here, let us say, so normally it is minus half g gravitational force t square plus initial velocity times time plus initial height. So in general, this equation is like this. So if you compare it with this equation, I think you can immediately find the solution, right? So I think there's one more question to go. Now this is a very interesting question. It says, if f of a equals to 0 and derivative at a is 6, then limit h approaches 0 for f of a plus h divided by 2h is what? So that's the beginning of derivatives. So we'll stop here now and take few questions which will involve a lot more derivatives. So what is derivative at a? Let's define that first. So when we say f prime a, which is derivative at a, is basically limit h approaches 0, f of a plus h minus f of a over h, correct? We are given f of a is 0, so I can substitute that here. We are given the derivative to be 6, so let's substitute. So we get 6 equals to limit h approaches 0 for f of a plus h minus 0 over h. So from here we find that 6 is equals to the limit h approaches 0 for f of a plus h over h. So we know this part, that is limit h approaches 0 for f of a plus h over h. So what is the answer for that? Half of this, right? So if I multiply by half both sides, I get what I need, and so the answer is half of 6, which is 3, right? So option B is the right option, correct? So with this we conclude our first set of videos, multiple choice on derivatives. I hope it's good for warm-up. So I'll take up next series where more calculations will be involved. I hope you appreciate it. Feel free to make your suggestions, and if you like and subscribe, that'd be great. Thank you and all the best.